And okay, let's go. And can you see my slide as full screen?
Yes.
Yes.
Okay. So, yes, we have drawn free body diagram. This one is for the both masses, free body diagram of these both masses, and this one is free body diagram for the upper mass. And again, your coordinate system will be like this. There's x-axis or horizontal axis will be along this rope, and the vertical axis will be will make a right angle with your surface. Okay, so and here you don't know this angle, right? You don't know this angle. What is theta here? You don't know this one, but you know this length of this inclined plane. From here, by using trigonometry, you can easily find this angle, right? So your angle will be equal to what? Tangent theta, you know, this one, this length, opposite component over neighbor component, right? So from the arctangent theta, by taking the arctangent of this quantity, you will get this angle. Yes, first of all, you know this angle here. And again, as your friend also said, your acceleration is here. Pay your attention here because your velocity, your speed is constant and your acceleration will be 0. Since the boxes move down the ramp, kinetic friction force exerted on the lower box, right, by the ramp is directed to up inclined plane, right? So your motion is along this way, your friction will be on this way, will be in opposite direction, okay? You know this one. And because friction forces tend to protect from your moving, right? So to prevent slipping relative to the lower box, the static friction force on the upper box is directed up the incline, okay? So M total for this case will be the mass of these two boxes here, 32 plus 48 kilogram, and total mass will be 80 kilogram. And again, and let's go with the solution of first part, and the forces on y direction for the both mass system will be like this. F net forces in y direction from the Newton's second laws will be equal to MI y, right? So here ay is 0 also. Apply the composite object, and in this case, n total, this one normal force will be equal to this one, right? You can easily see from the free body diagram. That's why we are drawing the free body diagram to solve such kind of problems. You can easily see the independent forces exerted on your system, okay? So this, you know that from here, these two forces must cancel each other. In this case, they are in opposite directions, so their magnitude must be same. So in this case, M total will be equal to M total G cosine theta, okay? So in this way, in horizontal way, you have a kinetic friction, right? What is kinetic friction? Kinetic friction force will be kinetic friction coefficient times weight of your object in this direction, of course, will be equal to M total, and G cosine theta, right? This one, nice one, yes. And so also we will do the same thing for the forces in x direction. Total forces or net forces in x direction will generate an acceleration um, correlated with Newton's second law. Of course, ax is here 0 because your velocity, your speed is constant. From here, what about f-axis and Fk, friction force, plus tension in the rope. They are both in this way, friction force and tension to the inclined plane on this way will be equal to the sine component of your weight, right? So, or you can write down like this, Fk plus T minus m total g sine theta will be 0, okay? Did you understand here? Oops. Nice, nice. And then what is t here? You will rearrange this equation for t. T in this case will be equal to this one, sine theta minus mu kinetic friction coefficient here, this one. And cosine theta m total g. When you calculate this one, you will get this one. Tension in the rope must be equal to this one. If your tension, if you apply lower end above than this force, you will generate an acceleration, okay? So part B, what are the magnitude and direction of the friction force on the upper box? Again, the Newton's second law in x direction because your motion will be in x direction. Apply the upper box gives static friction will be equal to mg sine theta, right? And from here, you will get this one, okay? And for each object, is net force will be 0. Please, you will see such kind of problems in this chapter. To gain practice, you should solve again and again you should solve again and again such kind of problems. Okay, after class, please solve this question again and arrange this equation explicitly on your own. Okay, if you have any question, please ask me. Okay, next one. And you have a setup like this. A camper hangs a 26 kilogram pack between two trees using separate ropes of different lengths shown in the figure, and find the tension in each rope. So, of course, we should do a free body diagram for this bag. This bag has a weight along the downward, right? This one. This is your point object as your bag here, okay? As the weight along the downward. This is T2, tension in this rope, okay? And this one is T1, okay? This is the free body diagram of your object, okay? You should do a free body diagram like this, okay? So, and your pack doesn't move, so it's acceleration in both horizontal and vertical direction 0, right? So you will apply only a Newton's second law, and the net forces on both way will be equal to ma and will be equal to this acceleration is 0 will be equal to 0, okay? Again, from this angle, because of this angle, both T2 and T1 has two components in x and horizontal or vertical directions, right? So you can easily see that there's the sum of these two vertical components will be equal to the weight of your object. Horizontal component will be equal to each other, right? So And as I said, T2 sine theta 2, T2 is one, T2 sine theta 2, or again, or I can show here, T2 sine theta 2 plus T1 sine theta 1, the tension along the tension component along the vertical way will be equal to weight of your object, or you can write down like this: T2 sine theta 2 plus T1 sine theta 1 minus weight of your object will be equal to 0. Nice. You have 1. As I said, what about horizontal way? Again, this horizontal component, in this case, will be equal to minus 2 T2 cosine theta 2 plus T1 cosine theta 1, in this case, will be equal to 0, or T2 cosine theta 2 will be equal T1 cosine theta 1, right? And using these two equations, we can solve what is T1 and what is T2. Okay, and then after you get this equation, only you will do some algebraic calculations here, and you will arrange this equation to solve this equation for T2 and T1, and using the second equation above, this one, using this one, and you will express T2 in terms of T1. This will be equal to, when you will arrange this equation for T2 and you will express your T2 in terms of T1, okay? You will express T1 in terms of T2. It will be like this, okay? So, and then you will insert T1 here, okay? When you do this, you will get this equation, okay? Again, if you arrange for T2 equal to this equation here, and then only you will put the numbers, and your T2 will be equal to this force. Okay, and then after you find the T2, and put the quantity T2 here, value of T2 here, and you will get T1, okay? And T1 will be equal to this one, okay? Easy? Okay, I assume it is easy. And now you have a setup like this: a horizontal wire holds a solid uniform ball of mass m in place on a tilted ramp that rises 35 degrees above the horizontal, okay? This is your wire or rope, okay? And the mass of this object is given as m, okay? And the surface of this ramp is perfectly smooth, which means it's frictionless, okay? And the wire is directed away from the center of the ball. Here is the center of the ball. Okay, center of the ball. And in part A, draw free body diagram for the ball. In part B, how hard does the surface of the ramp push on the ball? What is this? And how hard, what do you understand from this question in part B? How hard does the surface of the ramp push on the ball? What will you find here in part B?
Normal force.
Good. Yes, you will find the normal force. In part C, thank you very much. In part C, what is the tension in the wire? First of all, the free body diagram. We have the many free body diagram. It will be similar, and this will be your horizontal axis, and this will be your vertical axis, and this will be mass here, right? and the weight of your object, okay? And here's the tension in the rope, okay? So, as I said in the previous class, you can choose your axis freely, right? Did you remember? In the solution, if you look, and the x-axis chosen along the rope like this, okay? You can see here, okay? By using this, you can easily solve the question, okay? So that is why I'm choosing direction of coordinate system is very important. So y direction, of course, will be along this way, the vertical, the along the weight, okay? So in upward along the y direction, you will have weight here, okay? Along the x direction, you will have tension in this rope. Also, normal force, normal force, oops, normal force, I will show again. This is x direction or horizontal direction. This will be y direction. You know that normal force always must make a right angle with the surface, right? So your normal force in this case will be like this, okay? So now in your coordinate system, normal force will make an angle with this angle, of course, will be angle of the inclined plane, okay? So the free body diagram for this mass will be like this, okay? So now in part B, you will find the magnitude of this normal forces here. So from free body diagram, the forces in y direction, will be equal to weight of your object. There is no motion along this axis. So n cosine theta 35 will be equal to weight your object, right? So in this case, n cosine 35 degree minus weight will be equal to 0. From here, n will be equal to mg over cosine theta, and you don't know, you will give your solution in terms of m here, okay? So your solution, your answer will be this one, 1.22 mg. The normal force in this question will be equal to 1.22 mg, or the surface of the ramp push the ball with this force, okay? And the next one is what is the tension in the wire. So you will do the same thing, and in this case, T, tension in the rope, will be equal to N sine theta, in this case 35. You have found N here, and will be this one, right? So if you do this, T minus N sine 35 degree will be equal to 0. T in this case, put the N value from the first part of the question. T will be equal to 1.22 mg sine 35 degree will be equal to this one, yes. Okay. And this one. And you have a 2 meshes and 1 pulley, 1 rope system like this. And one is 20 kilogram. This one is 20 kilogram. Alpha, the angle of inclined plane is given 53.1. degree. Also, kinetic friction coefficient is given with 0.4 here, and I want to make an explanation. There's a difference between coefficient and constant. You know what is it? How do you know is one thing is coefficient or constant? How do you separate? What's the difference between constant and coefficient? Anybody in the class?
Coefficient can change due to materials, but constant doesn't change.
Another opinion? How do you recognize one thing is you see in the question and one quantity is given? How do you recognize one thing is coefficient or constant?
Hocam, I think the coefficient in front of the constant.
Coefficient is, for example, 2 raised to 3. So 2 raised to 3, that 3 is the coefficient.
Give me a constant example.
Constant is
Gravitational acceleration is constant or coefficient?
that is constant.
Constant, yes. Friction, coefficient, friction is mu k here, coefficient. And
Yes.
what is G? What is G? Gravitational acceleration as quantity. What is the magnitude of G? 9.8 meter per second square, right?
Yes.
Meter per second square. Constant has a unit, but coefficient not. Okay? Did you understand? Coefficient doesn't have a unit like this, mu k 0.4, okay? But constant is in the case of gravitational acceleration, G, or Boltzmann constant, okay, or the mass of electron is a constant, or natural charge in the universe, the charge of one electron. All of them are constant, and you should express your constant with its unit. Constant has a unit and coefficient not. Okay, you can easily recognize difference between coefficient and constant. Did you understand?
Yes, hocam, thank you.
No words, and let's turn again the question. So here, what must be the mass M2? What is M2 here? Of the hanging block, if it is descant 12 meters in the first 3 seconds after the system release from rest. Okay, nice. And you have a time here, good. And you have a distance. This mass will move along this way, and of course there is a force here because of weight and the tension in this work, also friction. Also, there is a motion here. So what is this? So if there's a motion, we should use kinematics formula, right? So that you have displacement, also time here. From here, maybe you can find the acceleration, right? So if you find the acceleration, you can use this acceleration in the second law of Newton. From here, you can find the forces. Good? And Newton's second law, we will apply each block here. And the standard kinematic formula also can be used to find the acceleration, as I said. And the acceleration in this question will be constant. So by using normal kinematic formula, you can find the acceleration. And the normal force M1 will be, from free body diagram, m1 cosine alpha, right? If you do a free body diagram, and this will be weight, this will be weight cosine theta, right? And this will be normal force, and this will be m weight sine theta or alpha, okay? Okay, free body diagram for this mass, and the normal force in this case for m1, this will be normal force, equal to m1g, or this will be weight of your object, time cosine alpha, okay? So in this case, friction force will be equal to friction coefficient times weight, okay? Apparent weight, of course, in this case, actual weight, this one, but the apparent weight in this system will be this one, okay? So you can easily find the acceleration, what you know, the motion for this mass in y direction. So we can write down y will be equal to y0, v0 t, v0 yt, right? Plus 1 over 2 a y t square, right? So y minus y0 in this case, v0y, your system in the initial case at rest, not motion, so will be equal to this equation, in this case, y0, y minus y0 equal to this one. From here, you want to find this one, ay, okay? Ay, because you know t here, and you also know this displacement as given as 12 meter and t here 3 seconds. You want to find this ay here. From here, ay will be equal to 2y minus y0 over t squared. From here, your acceleration in y direction will be this one, okay? For m1, what is n here? N will be equal to this one, okay? We have write down the equation here, and now put the numbers. When you put the numbers, you will get this one. So friction force here, this is the normal force times kinetic friction coefficient will be equal to your friction force, and will be this one, okay? Now, applying Newton's second law to the M1 here, as I shown here, and kinetic friction coefficient, as a tension, right? You're moving in on this way, right? The mass, the motion of this mass M1 on this way, so friction must be along this way, right? So tension in the rope minus friction force minus mg sine theta, the weight component, horizontal component of the weight, will be equal to m1 times acceleration. But solving for t, now solve this equation for t, and you will get this equation here, okay? Friction force plus mg sine theta plus m1 acceleration, and when you do this calculation, you will get this quantity. And now you will apply the Newton's second law for m2. m2 minus g, this one, the weight, the free body diagram for this mass, weight along the downward and tension along the upward, right? So this will be equal to, there is an acceleration in your system, will be equal to m2 times acceleration, right? From here, you want to find this m2, because you know this t here, you know acceleration. m2 will be equal to t over g minus acceleration. From here, your mass will be equal to this one. What's the last question? Any question? No?
Hocam, can I say something?
You can say.
Hocam, could you please say to Mehmet Hoca for check his email, because I sent him an email 3 days ago, but he didn't answer me yet.
When did you send?
3 days ago.
Please send again, okay? Okay, of course I will remember him, but send again, okay? Maybe
Okay,
your
hocam,
mail
appreciate
can
it.
go to his
Yeah, junk mail.
spam, junk mail, okay?
Yes.
Please send again. Yes? Okay, see you next week.
Okay, see you.
Hocam, see you.
See you.